Hello, and thank you for having me at 90 Days of DevOps. I'm looking forward to this talk. Hopefully, you all learned something, and hopefully, I'll stay in camera. It seems that I've kind of rolled out a couple times, so this will be interesting. But let me go ahead and go over my slides, and let's get started. There we go. So, hi, my name is JJ Asgar. I'm waving. There we go. Hi, my name is JJ Asgar, and I'm a developer advocate for IBM. And we're here to talk about migrating a monolith to cloud native and the stumbling blocks you don't know about. I really do have the email address of awesome@ibm.com, so you're more than welcome to find me there. And my job is to be accessible. So if you watch this and I've spurred some thoughts or some questions, never hesitate to reach out because I want to be accessible. So hopefully you'll learn something, and let's get started. So your company has finally decided to move to the cloud native ecosystem, right? You're at 90 days of DevOps. You're probably trying to learn how to move more into the more agile or more higher velocity ecosystem. So obviously the cloud native ecosystem is where you want to go. You've landed on containerization. You're trying to, you've containerized a couple apps here and there, and it's your first step. You've heard all you needed was containerize this thing and push it to Kubernetes or OpenShift or a thing called Nomad, and the cost savings will just come. And you've done this, and well, things just haven't gone as planned, right? Like just in general, things have just gone different. Some of the tech didn't work how you were expecting it would. And wait, what do you mean OpEx has gone up? Wasn't this supposed to save us some money? Simply said, the promise of containerization just, doesn't work if you don't do your homework. Sadly, most companies don't. And in this talk, I'm going to be talking about some of those few gotchas that I saw as a privileged person at IBM with all different enterprises. We're going to use the guys of something called Asgar Labs and see what they hit moving forward into this cloud native ecosystem. And hopefully you'll learn from their mistakes. So when you go down this path and you take this trip down this path, you'll feel more comfortable and be prepared for some of these possible issues. So what is Asgar Labs, right? Like who are these people that we're going to be talking about? And it's a multinational tech conglomerate bought hard into that VM ecosystem. There's still a lot of VMs out there. There's still a lot of VMware out there. There's still a lot of EC2 instances out there. And they make ones and zeros like no other company. But they noticed that they were falling behind, right? Like people aren't using VMs anymore, using these containers and this Kubernetes things. Like what's going on? Or for that matter, OpenShift. You should be using OpenShift. But in all seriousness, Asgar Labs is a collection of the different companies out there that I've taken the stories from that I saw the same issues over and over and over again. So yes, it's a fake company, and no, they're not hiring. So what did they think they needed to do? They thought all they had to do was take the migration from physical data centers or colocation or the VM ecosystem and use that exact same technique and move their monolithic applications into cloud native. The bare metal to VMs was the same as VMs to containers, right? That's one thing I've actually heard an executive say. Spoiler, it's not, right? It's a completely different technology stack, but unfortunately, there are a lot of people out there who think that's the correct way to go. So where do I come into this conversation normally, right? Like there's usually a place that I get introduced to this team as an expert. And I come into different places in different sections of Asgar Labs. Arguably, a lot of them have a few successful migrations, which honestly I beg to differ. And they're nowhere near where they thought they could be with the amount of time and effort and money they've invested and spent. I come in as that cloud native person, right? And ask some serious, but some simple, but yet very tough questions. So let's actually ask those questions here today. And so when you find yourself in this situation, you can ask these questions to your teams and then really sit down and try to answer these deceptively hard questions. My favorite one, and you'd be shocked, genuinely shocked, to find out how many people have no idea who actually containerized their app, right? That's the first question you should ask. Was it the developers or the operations team? where there are more than just a couple status meetings, you know, like occasionally getting together and talking about it between the project teams and who shipped it. Like if you're an operations team and you're tasked to make sure the application is up and running, and you have no expertise in running this application, but you throw it into a container and then run it, that is going to be completely different infrastructure requirements than your development team who comes along and containerize something and knows how to break up the application up or figure out the dependency tree or whatever is required to make it happen. So first question is who actually containerizes this application? Next question is why? Frankly, why did you containerize your app? Asgard Labs containerizes because they were told to. I've seen so many companies that said there was no other reason an exec needed to say their core software stack was now next gen. We get to travel now, and CIOs are flying around and they get their CIO magazine or CTO magazine, and they're looking for the next shiny so they can hobnob with the rest of them, right? Well, you know, it's the same thing when certain companies said they're on the cloud now. Like if you're just told to do it, you need to have a real question, or you need to have a real conversation on why. Because, you know, like if you're already in the black and making money off of software, why take the risk of moving it to cloud native? And we'll get deeper into that in a little bit. Next question is where did you deploy, or where are you planning on deploying your containerized application? The spurs from the conversation is the cloud you're using because of choice or an ELA. If you don't know what an ELA is, it's an enterprise license agreement. There's one company out there that has a relatively large cloud now that also has some software that a lot of people write emails and documents in. Well, if you didn't know, they have an ELA attached to when you buy some of the things to write documents or emails, and they will give you free credits on their cloud. Well, there's a lot of companies out there that say, well, we chose to use this cloud because, frankly, we got a bunch of free credits. Well, they have the drug dealer mentality here where they give you the first year free, and then all of a sudden they start charging you, right? So is this the best for your company, or is it the one you were forced to use? Like, you got to ask that question. If you're an ML company, frankly speaking, maybe that's not the right company you should be building this stuff inside of. Or if you need, you know, a lot of specific requirements for your applications, or for specific memory or specific hardware, maybe it's only available in a specific cloud and not something that you were forced to use. Like, you need to have this conversation with your decision makers, because if you're just forced to use a cloud and it's not designed for if it doesn't help with your application, you're not going to do it. Next question is pretty obvious, but you'd be amazed at how many people don't know. What did you actually containerize? This comes from the actual architecture of what you've decided to do. I believe in Asgard Labs once took a WAR file. Well, frankly, it might have been an EAR file. I don't really remember. And threw it into the Java Docker container and called it a day. They just took an EAR file or a jar file or a WAR file and just shoved it up into a Docker container. And this opened up so many different conversations. This has some real problems, right? Because the promise of containerization was just take code, throw it into a container, and then just run it on whatever you need to. But when you start looking at enterprise applications, they're WAR files or jar files, and they have dependencies. So let's talk about some architectural changes. Yes, I'm using the term architectural, very specific here, that's required to be able to be successful. 9 out of 10 times, and because, you know, of course, I work for IBM, I have to have, you know, WebSphere somewhere on my screen, right? No, come on, that was supposed to be a joke. Hopefully somebody laughed. Anyway, this was what most people think as what they need to do. Is they need to take their legacy application, shove it into something like WebSphere Liberty or Open Liberty or whatever, and then throw it up on Kubernetes or OpenShift. This is the replatform. I posit that this is just the first step. So many people think this is the only step, but this is just the first step, where you need to get it working inside of it. But this is not production ready by any standard, right? Like, this is just proving that your application starts. It shows up on port 8080 inside your container, and, now Kubernetes or OpenShift can route to it. But, URL is a problem. There's a whole other world around it that you need to pay attention to. Next portion is you got to actually refactor into microservices, right? Yes, you have to refactor into microservices. You start needing splitting your application up. For instance, here into a couple WAR files where you've got the migrated app that share like the IBM MQ or RabbitMQ or whatever MQ you use in the backend. So they're starting to communicate inside of the Kubernetes or OpenShift instance. This is important, right? Because now that you've broken these WAR files up, you can now start focusing on specific portions of the application. No longer do you just drop a massive WAR file or PHP file or Golang application or Python application. Now you can focus on bits and pieces of the architecture to be able to receive it or deploy it, which is much more important. It also means you don't have to like start up IBM MQ anymore. You can actually have an instance of it just running inside of the Kubernetes cluster where you could put in your dev environment or stuff like that. That's a different conversation. But the idea is that you start breaking up your monolithic app into microservices. But that's not it. You still need to actually move into something called the strangler pattern, where you start bringing those microservices smaller and smaller and smaller. So you can focus on very small bits and pieces of your application. That's the only way it works inside of Cloud Native. Because believe it or not, you're not going to have a dedicated Java application by the time you moved into the Cloud Native space. You're going to discover that maybe Java is not the right right programming language to do some of the number crunching you need to do for, I don't know, whatever your backend is, right? Like maybe it turns out using Node or Python, or for that matter, Go, is more efficient than running all this application as Java code. So you're going to start rewriting bits and portions of your application instead of just a bunch of Java stack to do it. And then inside of this, you discover that you have all these different things broken up. So you start talking, everything starts talking to one another in a much larger instance. This is hard for a lot of companies to really understand, because no longer is it just taking a container or spinning up a VM and running your application and deploying every 6 weeks or whatever. It's now deploying, like, frankly, whenever it merges to main. That scares a lot of people, and we'll talk about that more here in a second. So what are the architectural advantages and disadvantages of going down this path, right? Like to break everything up into microservices and do this. And of course, I'm not telling you how to do this, right? Like I'm just telling you that you're going to need to do this, which is a much larger conversation to have with your development team and your operations team, because people don't realize this until they're already down the path. They've already invested the time and effort. But the first advantage here, because you need to know like what you're getting yourself getting into, the first advantage is frankly the velocity, the ability to focus on very specific portions of the application in a containerized way, and I'm able to scope your clusters to what you actually need. Unfortunately, scoping your clusters to what you actually need requires a rather large rather far ahead understanding of what your application does. One big pod in the Kubernetes space is not as good as a bunch of smaller pods. So if you take a Java application, I know I'm picking on Java, but it's just really easy for enterprise people to get this. Is if you shove your WAR file into a container and spin it up inside of Kubernetes, that's not as good as a bunch of small WAR files or jar files for that matter that can horizontally scale and level load with Kubernetes. Kubernetes is just a scheduler. That's all it does. You tell it to run this container and it will just run the container. So few people realize this when they move into the space. They think there's this whole ecosystem around it. But no, you have to choose all these different portions and all these things you've got to do. So the ability to get this velocity and the ability to switch things out here and there, you need to spend the time and effort to understand how your application is done. But this also requires a higher level of cooperation, because now no longer, you're just going to have one person who understands everything. Now you're going to have a bunch of different teams that understand different portions of the application. This is also going to require you to build more advanced integration tests, which is obviously best practice, right? But at the same time, if your company or the way you do your software development isn't designed to do integration tests, that's going to be a hard conversation to have, because now all of a sudden you don't know where all different portions can fail. And then frankly, what scares most people out there is you're going to have a completely different deployment system, right? And there's this term that at least when I was doing this more often in the world, there was something called a CCB. And the CCB was the Change Control Board, and there was a group of people every Thursday afternoon, once a week. They're all like VPs, the VP of development, VP of QA, VP of operations, and VP of or the director of the team would meet together in a small little scrum room. And they would literally do a thumbs up to say, yes, we're going to release software this weekend. When I saw that thumbs up, that means I was waking up at 3 a.m. to release software. So I never wanted to see that thumbs up. But that means that there was literally a room full of people who were making a hell of a lot of money that actually would say, yes, we need to deploy software. Unfortunately, that still exists today in some certain companies. And yes, you might actually be moving away from the CCB, or the Change Control Board in this sense. This removes the middle management for developers inside the Cloud Native ecosystem. And when you start talking about that, that scares a lot of people out there, because now they have to trust the bots. They need to trust the integration tests. They need to trust the system they're creating to actually catch these things. So no longer do they sit and give you a thumbs up. Now, when you click that big green button to merge to main, something kicks off and something gets deployed. That scares people. And that level of support requires some real cooperation throughout the company. So, but at the same time, you got to understand, you might be doubling up on things. Yeah, frankly, you might be. You need to audit and verify that you aren't doubling up on technology and work. A great example was Asgard Labs had both a scheduler in their Java stack. Again, I'm picking on Java, but it's just easy for people to grasp. And they attempted to use Kubernetes to schedule the pods. So bear with me for a second. So they had a scheduler inside of their application, Java. It would kick off batch jobs. It did something like weekly or whatever it was. But they were also they weren't leveraging Kubernetes to do scheduling for those. So whenever the Java application kicked off the batch job, it would stay inside the pod, right? So now all of a sudden, one pod would grow to take up all the RAM on the node that was working. So they weren't leveraging Kubernetes at all for what it was designed to do. They were wondering why. This is actually when I came to the conversation. It's like, JJ, every Monday morning at 3 a.m., we hit 95% usage on our 3-node cluster. Why isn't this level loading? I'm like, oh, okay. They're like, yeah, we want to just spin up another instance of it. I was like, oh, it's pretty advanced. Multiple nodes using nodes to spin up and spin down. But I started really talking to them about it, and I realized that that's what they were doing. Their Java application was spinning up inside their pod, and you can't break pods across nodes. It just doesn't work that way. So I actually talked to them about it and asked them, hey, why don't you create this batch job as, another little microservice, right? Or microservice that runs these batch jobs, that when it's ready to spin out, it spins out new pods and it level loads across all of it. It took months and months of work to figure out how to spin that out of the application, et cetera, et cetera. But the idea was they created a little microservice that does this, and now they don't have to spin up a brand new cluster worth of resources to run this. Now it just level loads across it, which answered the question, but they weren't leveraging the Kubernetes to do what it needs to do. That's only just one example. There's also a built-in load balancing system inside of OpenShift and Kubernetes that if you don't know how to configure it correctly, that F5 that you probably have, you probably don't need it anymore, because you can do all the stuff you were doing with F5s inside of Kubernetes or OpenShift. And it's important to recognize this. You have to sit there and audit and understand what your application is doing. So isn't automation good here? Why are the things so complicated now? JJ, you've made this harder for me. Why are you making it harder? Is Kubernetes supposed to make, containers supposed to make my life easier? First of all, automation, right? Yeah, of course. Of course automation is important here, right? With all the moving parts, you need to leverage automation to take away the human error-prone portions out of the equation. Back to the joke about me waking up at 3 a.m, I would make mistakes at 3 o'clock in the morning when I was releasing the software. And with, when I now merge to main, the integration tests do all the work for me. But to get to that level of confidence, it takes a lot of time and effort. And complication, honestly, it's probably always been this complicated, but you've probably never been able to visualize this complexity, right? It's always probably been some of those enterprise architects that exist in your infrastructure that like understand the meme of Charlie from It's Always Sunny in Philadelphia, like with the red lines and all, right? That probably exists in a couple of people's minds. And people didn't realize how hard it is to run this application you're trying to do. But now that you can visualize it and you've broken this application up, you can start working and focusing on those bottlenecks and optimizations. When you truly get to microservices, you'll be amazed on the information you can get out of it, right? It takes a lot of time and effort, but you'll be able to optimize really, really well. Or as a good friend of mine used to say, with a macro service, you had a ornery bull mastiff. With microservices, now you have 13 yipping chihuahuas. If you don't know what a bull mastiff is, it's a big dog, right? You still got to feed it. You still got to walk it. But now you have 13 yipping chihuahuas. You still got to feed them. You still got to walk them. But it's a lot easier to move 13 yipping chihuahuas around instead of one big dog like a bull mastiff. And then also, on top of that too, if something goes wrong, just as Ken stole this quote and I'm stealing it from Ken, it really does become a murder mystery. Just take a moment and really think about this. No longer do you have, unless you've set up some aggregated log monitoring, every log file will be unique to each service. So you have to walk through each process and what happens and when, because that's what containerization is, right? Like you've isolated different portions of the application, and now you have to have a way to aggregate all that stuff when something goes wrong. This requires a standardized logging standard or standardized logging system or standard between all your different teams for production outages. If your culture does not support this, like if you don't have a trusted way to communicate back and forth, i.e. farther status meetings than just one or two, it's going to be really hard for operations to keep your application up and running. That'll require real outages. And with that, like that's real money lost. So you've got to really sit down there. So there's little bits and pieces here and there that you've got to really think about as you start going into this microservice ecosystem. So hopefully you've at least interpreted from what I've said is that it's not just code or the architecture that changes. It's also a huge cultural shift that has to happen. So let's ask these questions about the culture shift that's required, so at least you feel a little bit more comfortable about what will happen and how you will have to convince your executives that these are the things that are going to have to happen. I mentioned that CCB earlier, and at one of the companies at Asgard Labs had almost something like they had at the Phoenix project, right, at the very beginning. Nobody showed up, or if they did, they weren't engaging or just became a burden. And that's not good, right? Like you need to, with just like in the Phoenix project, and I forget the gentleman's name, the main character inside the Phoenix project, having people understand that it's not a burden to be a part of these things. When you're writing an application and trying to get it out to make money for the company, you need to be engaged. You have to understand what is actually happening. So you have to actually take some of those advices that gentleman does. When you're moving into the cloud native ecosystem also, you have to start allowing for self-orchestration, which is one of the largest cultural changes that has to happen, because like that CCB, there was one gentleman in there, I remember very, very vividly, that he did not trust because he had to take responsibility for what was being released out to the world. And he did not have the confidence that his developers were actually releasing good software. He would never let anything get released until QA like gave it 3 thumbs up, which was his term, in the QA staging environment before they could release it to production. Now, that's a different conversation to have about, the culture and et cetera, et cetera. But at the same time, that's a nice little microcosm of that man would never let self-orchestration happen, right? Because he needed to trust himself, because he had to other people trust that the thing was going to happen. So that would force you to build a lot of automation tests around it. And if your culture doesn't allow for that, the collaboration will never happen. And that's why you build that pipeline, right? Like that type of gentleman needs to be able to see all the green checkboxes to say that, yes, the thing is actually doing it. It's no longer his buddy Sammy or Sally or whatever it is. It's now Jenkins or whatever system you have, GitHub Actions, whatever, it doesn't matter. It comes back and says, yes, this is what I expected it to. But you need that CI and CD pipeline to actually trust it. And 9 out of 10 times, what you really need is a good CI pipeline to come back with the testing. And CD is frankly a lie, especially when you're just moving into this space. Because to get the level of confidence that you have continuous delivery, that when you click that merge to main button, it gets released, executives are horrified of that because humans, they still want somebody to actually click that button. So also with the CI pipeline that you have, you got to understand that you need to have some level of understanding of the code. I was an operator for a very long time, and there was we didn't have standardization for some of the Python code we were running. So we didn't have Black or pip 8 or whatever. So people would put the stuff all over the place, right? And at 3 o'clock in the morning, that level of frustration of me trying to read code to figure out where it went wrong so I can, restart the service in the correct way or whatever, or run the little function to do the thing. That's frustrating. If you have good CI linting and stuff like that, where it's just the beginning to have CI linting on all the different portions of your microservices and standardization, again, you're enforcing standardization with CI, that'll give you some level of sanity for your downstream operations users. So if you decide to use Python for one portion of your application, Node on another, and Go on one more, and then Java on another, if you decide that, okay, all these different applications, but we decided that the linters we're going to use are Black, JS lint, and Go format on these, then all of a sudden, that forces more standardization. It's because the code gets read through the CI platform and said, no, it turns out you're missing X, Y, and Z, or you had 3 spaces instead of 2 or whatever, right? This is just good practice to have. In that practice, because you have to learn to collaborate with other teams, all of a sudden the standardization is across all the different teams. One of the hardest things I ever saw, or still see for that matter, is the collaboration between teams. There's a lot of propaganda out there about having scrum teams or tribes or whatever they call them now, but the people just still want to do it the old way. Collaboration isn't just status meetings, right? That's the cultural change, is that it's not just, doing stand up every day talking about certain things. It's actually creating shared contracts between different groups of people. Actually discussing the jobs and the responsibilities of what the different features do is also very, very important. And the constant communication between teams to understand that, this is what we are working on and this is what we are trying to do. Jira tickets can only get you so far, right? Like Scrum Masters, they want to keep their jobs. I completely understand that. They want to keep their people in line. But when you start bringing microservices, you start really needing a level of interoperability that Jira tickets just don't have. You need to really start talking about certain things. One of the coolest things I ever saw, that to this day, I've done this talk a couple times now, and I've still haven't gotten permission to call the company out. But one company got one executive to their development team to change a person every single sprint to a new team. So they injected new blood every single 2 weeks with somebody brand new that needed to teach how they did this in their little microservice. For the first couple of months, there was a lot of pain, right? Because 2 weeks you were completely doing something completely new, completely out of your comfort zone, probably in the language you'd never written, and you're trying to produce something. But after a couple months of this doing, all of a sudden their getting started documentation was better. all of a sudden they actually started understanding what the different teams were actually doing. So when they went back to their normal team, not the one team they got pushed off to for a couple of weeks, they're like, oh yeah, I was working with this API with Jane Doe over there. Turns out they do this thing over there, and the reason why is because X, Y, and Z, because I actually understand what they're working on. And then all of a sudden the tribal knowledge is no longer inside the microservices. It's now expanded out to the larger group. And then the knowledge sharing becomes much easier. Unfortunately, again, you need to be willing to take a little bit of a loss to be able to gain that momentum, to share that stuff across it. One day I'll get that person to write a blog post or an essay or a book for that matter on this, but to this day, it still hasn't happened. But it's still, it's still important to recognize. So we're in a DevOps presentation. We have to talk about visibility and monitoring at some point, right? It's supposed to be a joke, but it's true, right? Asgard Labs, they thought they could just buy one product and call it a day in the microservices space because, they probably still use Nagios somewhere. Everybody still does, right? Well, it's not going to cut it. Whoever's trying to sell you the one product to rule them all, they're just trying to sell you a one product so they can make their sales quota. When you actually go into the microservices space, you're going to have multiple different monitoring applications. It's just that simple. Because you're going to have visibilities and they're going to have very specific tooling for the specific things they're looking for. As badly as those Asgard Labs companies wanted a single pane of glass, it's unrealistic. It just truly is. Because certain people are going to, like operations is going to need to see a completely different view than the development team about the different actual applications. There's just not going to exist anymore. And so it's a huge cultural change for Asgard Labs to do something like this. And frankly, a lot of companies are still dealing with this. Like you're not going to just go buy one thing to do this. Operations is going to need PagerDuty and to make sure port 8080 is up and running on some application. And then, your dev team is going to need an APM to understand why the SQL query is long or whatever. So it's important to recognize that. So, keep that in mind. I have to at least mention that, how the economics of the cloud differ than the data center, because you're moving into the cloud native space and people are going to ask, like, does this actually save us money? Well, CFOs still don't really know. Everything can be now paid with a credit card, as you all obviously know, because, that's the way the world is now. But CFOs really are having a real big problem with this nowadays, because it's really hard to depreciate OpEx. I mean, I don't think you can. But when you bought a data center and a bunch of racks of hardware, they could write stuff off on depreciation, which is really, really important, especially when you start getting into larger scales of stuff. But if it's just on their credit card, and if it isn't projectable, it's really hard to roll those numbers back up to the decision makers. So you've got to have your management team really have a real conversation with your people above them about, like, if we go down this Kubernetes or OpenShift path, we're going to buy all this hardware. We're not going to own it. We're leasing it. And turns out we had a bug that, spun up a bunch of different nodes now for some reason or another, because somebody decided to talk directly to the API for AWS. And oh yeah, by the way, we're going to spend $6,000 one month, and we're going to spend $100,000 the next, and then we're going to spend $6,000 and then $200,000. Those numbers are not great for a CFO, because they need projectability and predictability. So make sure your manager spends time in that space. Also, what do you mean all our support's in Stack Overflow now? Like, there's not a throat to choke? Like, what do you mean I have to go out to the community? Frankly, yeah, in a few places. And the cloud native space still is. You're going to find yourself going to KubeCon. You're going to find yourself where the open source engineers are. And you're going to have to actually engage in those spaces where they meet. You have to go to the SIGs and things like that when things go wrong. Okay, obviously I work for IBM, and we do have an enterprise offering of Kubernetes called OpenShift, which is pretty good, frankly. But where space you decide to go into the cloud native, you got to recognize it's not one company. It's a bunch of companies, and it's truly an open source project. So you're going to have to figure out the players are, engage with them. So let's talk about some tangible things you can start with to help to become more successful. There's tons of technology and software out there to keep you going. But the best thing you can do is to take a moment and figure out if and when you containerized your app, did you really containerize it, or did you just wrap a pod and wash your hands of it? That happens so often. It's unreal because people got the promise of containerization and frankly, the promise from Docker back in the day, and they're still thinking that's the way to do it. Have a large conversation about why you need to do this. Was it because you didn't want to get left behind like Asgard Labs? Or was it because you thought you could leverage some software and get a better value for your customers? It's frustrating. It really, truly is. So ideally, I'm asking all these different corporations and I've had exposure to as Asgard Labs, who's highlighted some of the inconsistency you can see. The best thing you can do is first ask if you really need to. And if you're committed, well, then you should probably take a beat and focus on optimization instead of features. This will drive your teams crazy, including your executives. But the more you pay up front and use the correct tool for the job, the better you'll get. And you'll be very surprised on how many people I've realized over these years, frankly, don't migrate your application to the cloud native. Build your next application for cloud native and get these things from the get-go. Because if you're already making money on your application, you will go into the red with, it might not be immediate dollars or immediate whatevers or currency, but it'll be engineering time that you will lose focusing on building this application to fit in the cloud native space when you should be focusing on your next application and get all the benefits from it from the get-go instead of being in the black, doing really well, going into the red for as long as it takes to get back into the black, which is not great for your business. It's really not, especially nowadays. Or to quote a great friend of mine, you wouldn't use a saw when you needed a hammer, or wouldn't you use a hammer when you needed a saw, right? Both of those will break pieces of wood if you needed to. One of them, you'll look like an idiot trying to, break a piece of wood apart with a hammer when you could have just used a saw. Or if you need a nail in a nail, right? Or a hammer in a nail and you used a saw. I mean, you could be a little wobbly, but you need to use the right tool for the right job. It's important to recognize this. And a lot of the time, using the wrong thing or migrating your application might not actually work. So that's what I got. Hopefully this has been enlightening and hopefully you enjoyed it. Again, at JJ Asgar, more or less everywhere, or awesome at IBM.com. And hopefully you all enjoyed it, as I said. And I look forward to what comes out of this event. And take it easy, y'all. Bye.